linear inequalities. This is the true lesson 4. Remember on the previous lesson, lesson 3, it said lesson 4 and we had to scratch it out and fix it. Well, this one's the true lesson 4, okay? Now, any point on a line makes that line's linear equation what? True. For linear inequalities, it's very similar, but the points above or below the line could make it true. But that very first statement, the point on the line makes the linear equation true. That's what we were looking at over here. Any dot on that green line makes the green equation what? True. Any dot on the red line makes the red equation true. And if you looked at a system where the red line hits the green line, we need that one special dot that makes both equations true, right? So we've got that going for us, but now we've got to take a look at these linear inequalities. They have those inequality signs. You know, the alligators, they always eat the bigger number, that sort of thing. Any point on there is true usually, but it gets a little dicey. So here's what I want you to do. You might want to put a box around these two symbols right here to draw your attention to your notes. You might want to do that. If we use them, I want you to use a solid line to show that the points on the line are solutions too. It'll make more sense when we do the third and fourth part on here. Now, how can we actually go and do this? Y is less than or equal to 4/5 x plus 4. Could you guys think of that as an equation? Can you think of that inequality sign as an equal sign? If you do that, then we should be able to go and graph it. What's my y-intercept? 4. You can see it right there, right? 4. Now, my slope is 4/5. So I should come up 4 and over to the right 5, right? Somewhere right in through there. But I'm off the grid, so what do we have to do with our slope? Make it into -4 over -5, and that means we could come back this way. Whoops, back this way and down this way, right? Does it look like our lines would line up with the dots, yes or no? So the only thing that you really need on here, I'm going to kind of clean this up, are our two dots right here, okay? Draw a straight line as straight as you can and just connect it. I'd like you to take your pencil and I'd like you to call this dot A, point A. And I need somebody and look, do you have space down here below to write? You've also got space up here at the top to write. So what I'd like you to do is write down point A with its X and Y value. Who's going out at point A? Let's see here. -5 is my X number. What is my Y number? 0. I want to check to see, does this point make that inequality, what's the word? True. So I'm going to take the Y value, which is 0, and put it right here. 4/5 will be multiplying -5, and then we add 4. It looks like we've got some calculator work to do. In other words, what is 4/5 times -5 plus 4? You're absolutely right. It does become 0. Now, because it's got the equal sign, that little line underneath less than, because it's got the equal sign built into it, does 0 equal 0? So it makes it, what's that word again? True. So any point on that line should make it, what's that word again? True. But because it's inequalities, it can be less than, it can be greater than, it's more than just what's on the line. Now, do you have that colored pencil out and ready? Do you see that we have this Y here sitting all by itself? It's the Y by itself, yes or no? But then it's Y is not equal to, Y is less than, or equal to, but less than. So take a look at, what letter is that? What letter, X or Y? What letter's all by itself? Y. So take a look at your Y-axis. Take a look at your Y-axis right here. What would be less than, above the line or below the line? It would be below the line. So with your regular pencil or your colored pencil, I want you to put a little down arrow. So when you see less than, that means we need to shade below the line. Now this one, you're going to want to be like taking your time, but I don't have forever for this. You can come back and make this pretty. You shade up to the line right here. You don't go over. I'm trying not to go over. Come all the way over here, and I want everything shaded in right here. Okay? Okay. Now, I need us to go back with our regular pencil, and I want us to put a dot right here at the origin, and we're going to call this point B. That is in our shaded range. That means if it's in our shaded range or it's on the line, it's going to make it true. So what is point B? Well, it's 0, 0. So let's go plug in our X and our Y values, and let's just go see if it makes it true. I get 0 as less than or equal to 4. Is that a true statement? Is that a true statement? Yes. So because it said less than or equal to, it's like, hey guys, you can take all those points that are underneath the line, anything, and it's going to make it true also. Anywhere in the shaded region, just as long as it's below the line. Or can it be on the line? Yes, it can be on the line also because of the equal sign. So let's go through and let's just choose this other one right here. Let's choose this one as point C. This is going to be the only one that we do it like this. It's the only one where we're going to go and check it. I want to check a point that's in the non-shaded region, and I want to see if that actually makes it true, because it shouldn't. It should make it what? False. So let's go check that one out real quick. And I use different dots at different points on different classes. I'm using -2, +4. So 4 is my Y. This is -2. Let's go see what we get. Oh, wait, this is less than or equal to, right? Sorry about that. I got 4 is less than or equal to 12/5, or, you know what? It'd be 2.4. Is 4 less than 2.4? Is 4 less than 2.4? No, so this one didn't make it true at all, did it? And just look at your graph up here. Point C, where I grabbed it from, was not on the shaded side. So do you understand what I'm talking about when I say the shaded side will give you all of the answers? Yes or no? All right, let's go on through this part real quick right over here. Let's go to number 2. We have the y-intercept at -3. We would go up 5 and to the right what? We're going to go up 5 and to the right what? 3. Put a dot right there. Go ahead and make a solid line because we have the equal sign on that inequality. Now, it says greater than. Do you see this greater than symbol? Should we go above it or below it? Above it. Okay, so now I just need us to go and shade, and guess what? We're done. There we go. That's it. That's number 2. Is that easy enough, folks? Let's go down to number 3. If you see that the inequality signs are just greater than or less than, they are not having the little equal sign, I need you to do a dashed line. Now what that means is hey, any point on this line is not good. Remember open dot and closed dot for linear inequalities? This would be like an open dot saying, no, 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 nothing on the line is good. We just want the shaded area. You can get up to the line, but you can't get on the line. So let's go graph this one right here. Hey, +1, and then our slope, isn't it, going up 1 and to the right, like this? So this is our line, but because it is does not have the equal sign on the inequalities, what I want you guys to do is just put dashes on here. We don't want to see a solid line. We want a dashed line. That means, look, anything on that line will not make it true. It's a rule. That's what it comes down to. It's your way of saying, hey, look, the line is not good. The line is not good. The line is the boundary line, but you can't put a dot on that line to make it true. Now, should I shade above or below? It says greater than, so y is greater than. So I shade above it or below it? Above it. Now let's go shade it. All right, so I'm finishing these notes up after everybody's left. Number 3, you can see that any spot in the shaded area would be a solution. So I'm going to put this one on right here, and you don't have to put this into your notes. Point A is in the shaded region, so that would be a solution. Check. The XY would make it true. Now, if I went onto the line, like right here, let's call this point B. Sorry, that's on the line. Because it doesn't have the equal sign underneath it like that, we're saying, hey, the line needs to be shown as dashed, so that way we know, hey, the line is off limits. That will not be a solution. And then, of course, if we had C down here, this would not be a solution either. Okay, so I'm going to take those off there, and we'll kind of clean that up. And let's go through and take a look at number 4. Y is less than 5/2 x minus 3. So we have the y-intercept at -3, and we would go up 5 and over 2. Gets us our second dot. And we draw our dashed line. Now, you can see that that is kind of crooked. So what you might want to do is just very lightly with your pencil actually take the time to draw in a solid line. And then just take your eraser, and because you went kind of light, hopefully, you can just come back through here and be like, yeah, let's just put some spaces in between there so that way it's not a solid line. And then take a look at that inequality sign. Since it's less than, we would want to shade below. And so the shaded region is all of your possible solution points for that inequality. And it's a lot. Any dot that's on the line, because it's less than, it's not less than equal to, would not be a solution. Okay, it's just like a boundary line. And then obviously anything not shaded is not a solution either. Flip it to the back, we're going to take a look at horizontal and vertical lines. First off, we'll do the vertical lines. X is greater than or equal to 5. So you put a dot on your x-axis at the number 5. And then because it has the equal sign part right there, right? Because it's got that little extra part, we use a solid line. And then we ask ourselves, how should I shade? Well, this is a vertical line, so we either have to shade to the left or to the right. And if you notice, the x in the inequality is all by itself. And we're saying x is greater than 5. Well, 6 is greater than 5. So basically, that means that we're going to be shading to the right. So any dot in the shaded region is a solution. Any dot on the line is a solution because it has that equal sign underneath the inequality. And any dot that's in the non-shaded region is not a solution. On number 6, it's almost the exact same thing. In fact, I made it this way just so you could see the difference, the very subtle difference. We're still going to be shading to the right because it's greater than, okay? We're still going to put a dot at 5, and it is a vertical line, but because it is just greater than, not greater than equal, we're going to use a dashed line, okay? And we shade to the right. No worries. So anything that's in the shaded region is the solution, but because it's greater than, because we're using that dashed line, that's just a warning to us of, hey, anything that's on this line will not make the inequality true. And then again, anything that's over in the non-shaded region is not a solution. Let's go down and take a look at the horizontal lines here. Okay. So y is less than -3. So we just have to put a dot very quickly here at -3. It does not have an equal sign, so it needs to be a dashed line. And then because it is less than, we need to shade below. Same thing as before, anything that is in the shaded region, those dots would be solutions to the inequality. It will make it true. Because it doesn't have an equal sign and we use that dashed line, anything on the line is not a solution. And then anything up here in the unshaded region up here, that is not a solution either. Let's go to the very last one. Y is greater than or equal to 0. Because it's got the equal to part on there, hey, we actually get to use a solid line for a change. So there we go. and it actually becomes the x-axis. That occasionally happens. And because it is greater than, we want to shade everything above, right? So it takes a little while, and anything that's being shaded in here, any of these dots would make it a solution. It would make it true. Anything on the line would also make it true, but anything in the non-shaded region, sorry, not a solution. And that is how we handle linear inequalities.